Hello world, and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Wendell. Today we're going to be looking at our second solution for app migrations into Azure, and this is going to involve looking at containers. Hi guys, today we're going to be taking a look at solution number 2 in the 3 solutions that we're going to be looking at for moving apps up into Azure. Last time we looked at infrastructure as a service and how you can use that to host applications on Azure, and we talked about the pros and cons of doing it that way. Today we're going to be looking at containers. Now containers are a viable option for a number of different applications. They offer a lot of value add. In many cases, they are nice for moving existing applications into Azure. This particular application that I'm going to be migrating into Azure doesn't really have a lot of benefits from containers, but I do want to show you that it is possible with some refactoring to move our application into Azure using this approach. So let's go look at the problem and then look at the solution, and then I'll show you how I implemented it on Azure. So as you may recall, this is the application that I've been working with over the last few weeks. It has a browser-based front end that is used by the user to either look at images or tell the backend system to print the image. And the backend system runs on a web server and it interacts with some kind of file storage that is connected to that server. And then once an image is sent off to the printer, first it interacts with a print server right here, and then that sends a image off to the photo printer in the back end so that it can then be rendered on that printer. So this little application is an application that requires some things to remain on premise, which is basically going to be the print server and the printer, because I can't move that hardware into Azure. However, I can host the application on Azure, and that's exactly what we did with infrastructure as a service. We basically took the application as is, moved it into Azure, and we used virtual machines to host it on. We used Azure file stores to host the images, and everything worked great using that solution. I didn't have to change any code. To make this run on a container, I needed to change some of the code, not a lot of it, but just some of it. And so it required a minor refactoring. And so instead of using the actual VM, I used a container to host that on. And because the container has limited print functionality, it is possible to print from within a container, I needed to come up with another solution for that. And so I did, and I basically just refactored that part of the application so that it would work fine in a container. And on Azure, this is what the solution looks like. And so what I ended up going with was a container on an Azure app service. Now, app services can run containers. It's not the only option on Azure. And this is the real value add of containers in many cases, is that they're very versatile. So you can host them on something like Azure Kubernetes Services, which is a full-blown cluster for hosting those. You can host them on Azure App Services, which is generally good for a few containers, but not a large deployment. And you can also use something like Azure Container Instances, which are good for more transient type workloads. But given that this is more of a web-based application, it made sense to put this on app services. So I configured app services to use Azure files, and similar to the way that the VM did. And the great thing about a container on an app service is that you can mount Azure file storage into the container. You can't do that with just the hosting that's available as a first-party hosting service on an app service. So I am running a Node.js app. I could run that natively on the actual app services, but I couldn't mount the storage. So putting it in a container gives me that ability to connect by way of a private endpoint over to Azure Files to load that data into the actual app storage there. And then from there, I can then communicate over a VPN using the VNet integration from app services back over to my print server here over a VPN. So the integration with the VNet allows me to have my app service act like a virtual machine, but I refactored some of the minor print components of this so that I could just take advantage of using that backend system that I currently have in place without having to rewrite the entire application. And this solution does work. And so it does allow me to send a print job from app services over a VPN onto my printer, and I'll show you that in just a second. But I wanted to go look at the code implementation of this first, just to show you this small minor refactoring effort that I did do, and to show you kind of the solution there that I came up with. There's probably other ones that are probably more elegant than this one. However, this was just one that I came up with that demonstrates the concept of what I'm really trying to do here. So this is the solution folder for this particular solution, and I have two folders in it that I'm going to talk about. I'll get to this one in just a second, but this one contains all the code that is going to be used by the container. So this is the Docker file that builds the container image, and this right here is the actual app itself. It's the service side of it, the server side of it. So if I open this guy up, what we're going to see is my code, and this is where I did the minor refactoring effort that I did do on this. I originally was going to try to do something like cups and use the common Unix print system on a Linux container to try to invoke a printer job across the network using that. I had mixed results with that approach. Instead, what I ended up doing is I basically just ripped out the guts of this piece right here and replaced it with an HTTP post. And what that HTTP post does is it takes the image and then sends it over the wire over to a print daemon. And the print daemon is what is in that other folder that we can look at here. And this print daemon right here basically receives that image and then prints it. So this is basically the same code that was running in the original version, but in this case, all it's doing is receiving the image and then printing that image, and instead of doing everything else. So it looks pretty much like the original code did. Instead of doing a print job directly, this one is receiving an image and then printing it using the exact same execution of that DLL for printing the image like I did before. So again, this is a fairly low-tech way of doing this, but this solution does work, and it does work fairly well with minor effort on refactoring. So I ended up going this solution anyway. So let's go over to Azure and take a look at what it looks like in Azure, and then we'll show you what the application looks like when it's running. So I'm here in the Azure portal, and this is the application that I have set up here. Now, it's using a lot of the same infrastructure that I had from my last one with infrastructure as a service. So that's why I'm calling this a lift and shift resource group. I'm just recycling some stuff here. So the actual app service is where a lot of the magic happens. So the rest of this is pretty much the same as the infrastructure as a service implementation. So I have a storage account for the file shares, and then I have a VPN for the on-premise connectivity, and the app service is really where everything else happens. So I'll drill into this, show you the details here. So the way that I am able to connect to the back-end file systems for this is using the path mappings feature available to containers on an app service. So basically it just allows me to use Azure Files to mount a mount point inside of the container at images, and then that's where I configure the application to read the image data from, and it's then reading that off of Azure Files in that case. So that's where the images come from. And then the networking allows me to do VNet integration right here. So this allows me to integrate this with the VNet, and so I can reach across the VPN to the backend systems, such as the print server if I need to, for this particular application. The rest of the Azure Landing Zone, though, with the Azure VPN, the storage accounts, and all the RBAC and everything else that I have configured for this is exactly the same as I would have it for the infrastructure as a service deployment. And so this particular application is really not really any different from that context. The biggest difference is that I'm hosting this in a container and putting this in app services. I don't have to configure high availability for VPNs and load balance that and firewall and do all that. I let Azure App Services take it, do all that for me, and I don't have to worry about it. And so there is some realized benefit there, but I don't think there's a lot of realized benefit and other contexts for this particular application. So let's just see what it looks like. Let's pop open this URL. The login looks the same because it's using the exact same login mechanism as before. There's nothing different about that. If I log in, it's just showing the pictures. These are loading off the actual file share. And if I hit show, it's going to zoom in on the image, and that's exactly like we had before. And if I hit print, this is where it's actually going to print it, and that's going to send it back to the back end. And you see image DJI 01 JPEG into printer. And if I pull up the actual server that's running on, the print server that I have this running on, this is the daemon running right here, and it's popping up a save as because I currently have it configured to save to a PDF right here. And so I had the printer set to the Microsoft PDF, and rather than going to the printer, I have it going to Microsoft PDF right there. So that was invoked by the print API that received the image and then printed it. So just to show you that I'm not doing smoke and mirrors here, we have one image printed here. Let's print DJI 0004.jpg and print that one. And that should send that over to the printer. And if I go back to the actual host of that, you can see that's the image I just received, and it's asking me to replace that. And if I go open that image up, I should be able to see the image printed inside of that PDF document right there. And this is not the fastest machine in the world, so it does sometimes takes a while to open up applications. It's kind of an old machine, so it's not really used for a lot of stuff. And there's the image that I just printed, so you can see that there. So in any case, the image right there got printed across a VPN over the network from an Azure App Service, with an app running in a container with stuff stored on Azure files. So let's look at some of the pros and cons of doing this, and then we will call it a day on this particular solution. So the solution to pros and cons, this one again, I don't believe has a lot of benefit. The biggest benefit is I get cheaper hosting out of this because app services are generally going to be cheaper than hosting on a VM. With a VM to get HA, I would have to configure the HA environment. I'd have to have something like an application gateway or in front of that to do the load balancing. And I would have all of the overhead of the operating system to maintain that, and blah, blah, blah. There's a lot of things that I could say to that. But overall, I think it's a cheaper solution. But it does require, refactoring. It does have is prone to outages because of dependencies on VPNs and things like that. And it's also introducing some probably less familiar technology, although containers are becoming more mainstream now. It's still unfamiliar to some folks. And so these are definitely some of the cons associated with that. What we're going to look at with solution number 3 is hopefully the best solution, I believe, that will give me probably the cheapest hosting option and the most reliable hosting option for running applications. So it's a complete refactor of the entire application, but the results that I get very, very, very economical hosting, and we'll see that realized when we go into the demo on that particular application.
If you like this content, please consider visiting us online at www.wintellect.com, and there you can find about services that Wintellect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintellect on Twitter at WintellectNow or at Wintellect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintellect.com. Until next time, thank you.